having, if we are having 1:2, means I am having 1 divided by 2. So I can write it in another form, that is 1 by 2. If we are multiplying numerator and denominator with the same non-zero number, what we will be getting? 4 into 1, answer is 4, and 4 into 2, answer is 8. So 1 by 2, ratio 1 by 2 is same as ratio of 4 and 8, that is 4:8. These both are same. Only thing they are having some common multiple. Right now we can see that 4 is the common multiple and 4 is acting as a constant k. Okay. Before proceeding with further problems, also we will like to know what is the proportion. And in proportion, we are having two types, that is direct proportion and inverse proportion. Now, what do we mean by direct proportion? Direct proportion means when first quantity, say A, increases, then B increases. If A decreases, then B decreases. This we mean by direct proportion. And what do we mean by inverse proportion? A increases, then B decreases, and vice versa. Means when A decreases, B increases. This you should remember as a proportion, a very important concept. Again and again in variations, and you have already done this in 8th standard, I think so. So this you should keep in your mind when two quantities are given. We'll be taking one example based on direct. If cost of, I'm doing an example of direct first, then we'll be doing for inverse, which says if first quantity increases, then second quantity increases. Suppose that if cost of 1 liter petrol is 80 rupees, then what is the cost of 2 liter petrol? And what is the cost of 2 liter petrol? Yeah, it's very obvious that if cost of 1 liter is 80, then cost of 2 liter is rupees 160. Here we have seen that 1 liter 80 rupees. So 2 liter 160 rupees. As A increases, value of B also increases. It increases from 80 to 160. So from here we understood the example of direct proportion, and now we'll see an example of inverse proportion. So these are like this is for your day-to-day life example where you can understand how this direct proportion and inverse proportion come into existence. how this direct and inverse proportion come into existence. So let's do one real life example of inverse proportion, which states that how two quantities are related. One increases and another decreases. Say if 10 workers, all of you know Maths1, they're working, they're constructing our houses in chawls or in buildings, in construction line. If 10 workers complete, this is just for understanding, I'm not calculating it, so that you can understand. If 10 workers complete any work in 5 days, any given work in 5 days, then how much time 15 workers will take to complete the same work? Automatically means approximately they will be taking 2 to 3 days. This is for your understanding. As we know that worker increases, the number of working days will decrease because they will be completing the same work earlier as the load of the workers increases. So this is an example. Here we can see that one quantity, that is workers, and here days. When workers were done, 10 days required was 5. When worker increased to 15, the days reduced to 2 or 3. So from here we understood that if worker increases, day decreases. So this is an example of inverse proportion, which is like our day-to-day life example. So how important this ratio and proportion are, and how we can apply this concept in our day-to-day life. From these examples, we have understood. Now, what we will be doing, we'll be doing some properties which is being given in a textbook, and solve examples, and after that we will move to exercise. Okay, so let's start with the properties first. Okay, so now properties of ratio. First property is that ratio of numbers a and b, okay, is written as a is to b or a divided by b, which we have done at the initial stage, means to earlier today. Is called here a will be called as predecessor and b is called as successor, that is second term. So ratio of any two numbers, say a is to b, or a divided by b, or ratio of a to b. These all are the ways of expressing ratio. So a by b, in this term, that is a by b, the term or the number which is in numerator, it is called as predecessor, and the number b which is in denominator is called as successor. Okay. So from here we have understood that the number which is present in numerator is predecessor and the number which is present in denominator is successor. Hope this point is clear to everyone. Now we'll move to second point, that as we have done lots of problems of ratio earlier, just want to know 1:2 is written as 1/2. Okay, we are taking a simple example so that we can understand easily. I want to convert, I want to get the percentage of this. As everyone knows that whenever we are having a distribution of any uh, types, for example, we will take an example of when our parent brings chocolate for us. Suppose that our dad brings one Cadbury and we are having two persons at home, that is one sister, one brother, or both of them are brother or both of them are sister. So chocolate is one and we are two. So how to distribute such that both will be happy? If we will give one to one person and keep other person as it is without chocolate, then he or she will be unhappy. So in order to keep both happy, and will do, they will distribute the chocolate in such a way that both of them get half of the chocolate. Okay, so that is termed as half. And by observation, we have understood that one part is being distributed in two. Means we got 50%, 50%. This is by understanding. But mathematically, how to say that it is a 50%? Now we can see that it is 1/2. Now, we can convert this to percentage form only if we are having 100 in denominator. We should have 100 in denominator. Now, as we know that we are having 2 in denominator, what should be multiplied to 2 so that it get converted to 100? We can multiply 100. Sorry, we can multiply to 50. 50 in denominator, 50 in numerator. 1 into 50, answer is 50. 2 into 50, answer is 100. So this is 50%. Hope this step is clear. So whenever, which is our second property of ratio, if in the ratio, if we are having 100 in denominator, then that ratio is termed as percentage. And that is termed as percentage. Okay, now we'll go to third property of ratio, which says that if we multiply or divide, the ratio by any non-zero number k to both the numbers which are in ratio, it remains the same. It does not affect. We have done that examples also, but I will repeat it again. For example, if I'm having in general, A is to B is A by B, which is same as KA by KB, where K is any non where K is any non-zero number. Okay, K is any non-zero number. In particular, if we want to understand, we are having 3 by 7 as a ratio of two numbers, 3 is to 7. So if we multiply 3 by a non-zero number 4, so we have to multiply same number 4 to 7, and from here we can conclude that 3 into 4 is 12 and 7 into 4 is 28. So the number of the form 3 is to 7 is same as 12 is to 28. We can write this 12 is to 28 as 12 is to 28. 12 divided by 28 is same as 12 is to 28. Okay. So from here we have concluded that if we are having any ratio, if we multiply or divide, Multiplying and dividing means the same here right now, because right now I have multiplied, but even though I will divide, it will become the same term. Let's see that. How? A by K upon B by K. We have to show that A by K upon B by K is same as AK BK. How? This can be written as A by K divided by B by K. Okay. Whenever we convert division to multiplication, it gets reversed. A by K into K by B. And you multiply it, what you will get? AK by BK. Done. So we understood that whenever we first time we have done multiplication of K in numerator and denominator, we got AK by BK, and next time we have done A divided by K upon B upon K, which again we got it as AK by BK. So both means the same. Okay, this was the third property. Now next property, the quantities taken in ratio must be in the same unit. Now, when it comes to unit, for example, again we will be taking real life example. We go in a market, we purchase uh, any groceries of the type. For example, we have asked for 1 kg sugar, and we have asked for 500 grams besan. Okay, so 1 kg sugar and 500 grams besan. Now, can we express it as 1:500 as a unit of first entity, that is sugar, is in kg, and second entity, that is besan, is in grams, and we express it as 1:500? No, we cannot express, because it will create a mess, like as both are not in the same units. Expressing any quantities in ratio form, make sure that they are having same units. Because of that only, any two quantities or entities, when expressed in a ratio, they are unitless. We never write unit when we express two numbers in ratio. So this is a wrong way. First convert 1 kg to grams. 1 kg is equal to 1000 grams. Now you can express. You know that 500 grams is nothing but half kg. The ratio should be half. So common understanding, 1000 divided by 500. We are having grams. We are having grams. Get cancelled. What remains? 5 ones are 5 twos are 2 upon 1. So ratio is 2:1. This is correct. If we will ask ratio of besan to sugar, then it will be half, as we have asked sugar to besan. So ratio is 2:1. So from here we have understood that whenever we express entities in ratio form, they should have the same unit. Okay. Now we'll move further. Last property is that the ratio of two quantities is unitless. As I've explained you right now, that whenever we are having two entities in ratio form, their units get cancelled and the ratio becomes a unitless quantity. So ratios are always unitless. Ratio of two quantities are ratio of two quantities is always unitless. So please remember whatever we have done in properties, it is very much required to solve the problems which is given in the exercises. So let's start with the solved example. First, we will do the example of the length of a rectangular field. Okay, now how to solve this problem? First, read the question carefully, find the data accordingly, express them. If they are having same units, then not an issue. If they are having different unit, try to convert them to same unit and then express in the ratio form and get the answer. This will be our intention. First, check whether the given data is in same units. The length of rectangular field is 1.2 kilometer and its breadth is 400 meter. Find the ratio of length to breadth. So solution, let let small l be the length, let small l be the length and small b be the breadth of a rectangular field. Okay, so we have denoted length as small l and breadth as small b. So given L is equal to 1.2 kilometer and small b equal to 400 meter. So as we can see that they are not in the same unit. Length is in kilometer form and breadth is in meter form. So we will try to convert length to meter form. Let's see how. We know that we know that 1 kilometer is equal to 1,000 meter. Okay, so 1.2 kilometer is equal to 1.2 into 1 kilometer. You can write 1.2 kilometer as 1.2 into 1 kilometer, which means the same. Way of writing is different. So this is one of the easiest way to write so that you can convert. Otherwise, the student get confused how 1,000 came into existence and all that. So 1.2 into converting 1 kilometer to meters, so that is 1,000 meter. Hope you have copied this part. So after multiplying 1.2 to 1000, what do we get? We get 1200 meter. Therefore, ratio of length to breadth L is to B is equal to, what is length? Length I got it as 1200 meter divided by breadth is 400 meter. 0 gets cancelled, gets cancelled. 4 3s are 4, 4 get cancelled. So what we get? We get it as 3:1. So at last we can conclude the ratio of length to breadth therefore the ratio of length to breadth is 3:1. So next problem. Hope you have understood this problem. Whenever we are having the terms expressed in two different units, we have to convert both the terms or both the numbers to the same unit and then proceed with having the numbers. If they're having any common multiple, let them get cancelled. Whatever remains is the ratio. Okay. I will move to next solved example. That is the ratio of expenditure, ratio of, this is an easy problem. Let that be, you can do it by yourself. We'll be doing a fourth example, which is a word problem, which will help you understanding the problem which is an exercise. One of the important problems, right? The ratio of numbers of mango trees to chiku trees in an orchard is 2:3. Okay. So as they have given the current ratio. I've told you earlier that whenever the numbers are in ratio means they're having some common multiples. We don't know the exact number, so just take the common multiple to be x. So the number of mango trees be x and the number of chiku trees be 3x. Okay. After that, if 5 more trees of each type are planted, 5 more means just add 5 to mango trees and add 5 to chiku trees. Okay. Then the ratio will become, or ratio of trees would be 5:7. Find the number of mango trees and chiku trees in the orchard. Okay. How to solve this? Let's do it with proper understanding. I've told you that whenever we don't know the exact number, if we are having any two entities in ratio, means they are having some common multiple. So you can take any common multiple, either x or a or b or whatever you feel like, but your method should be correct. Your understanding should be correct. Not compulsory that you should take x only. We can solve it by taking a also. So let solution. So since the ratio is given to be, wait students, I will take textbook. Thank you. as we were doing a problem. 1 second. Sir, mobile, it's a speaker. As the ratio of trees are in the ratio two is to 3. Let the common multiple be x. Therefore, as we have taken a common multiple, now we can we don't know the exact number, but we can write that number. See how? Therefore, the number of mango trees is equal to, as we are writing ratios of mango to chiku. So mango will be 2x. First number indicates first entity, and second number of the ratio indicates the second entity. And the numbers or number of chiku trees three x. Okay. After this, according to given condition, when we add 5 to both, as they are saying, if 5 more trees of each type, mean 5 should be added to both the numbers, that is 2x plus 5 divided by 3x plus 5. Hope you understood this step. 2x plus 5 upon 3x plus 5 is equal to 5 by 7. Okay. Why 5 by 7? As they are saying, if 5 more trees of each type are planted, the ratio of trees would be 5 to 7. So this is the condition. Now we will solve this. We will solve this to get the value of x, so that we can get the exact value of, because our intention is to find the exact number of mango trees and chiku trees. So now, how to solve this? Do cross multiplication when we'll be taking 7. As we can see, 7 on the right hand side is in division form. When it will come to left hand side, it will become multiplication. 7 into 2x plus 5 is equal to 5 into 3x plus 5. Taking this term, the term which is present in denominator on left hand side to right hand side, it will become multiplication. Okay. Now open the bracket. What you will get? 7 2s are 14x plus 7 5s are 35 is equal to 5 3s are 15x plus 5 5s are 25. Hope this is okay. Now what do you do? Just take this 14x or the terms having variable x together and the constant term together. So we can take 14x to that side. So it will become, and constant term to left hand side, 35 minus 25, as it was positive on right hand side will become negative, and here also 15x minus taking 14 to that side, and it was positive will become negative. So 35 minus 25 is 10 is equal to 15 x minus 14x is x. So that is value of x to be 10. And after that, the numbers of mango trees, you can use this statement. Therefore, as we got the value of x, as 10, so 2x means 2 into 10. 2 into 10 is nothing but 20. And the number of chiku trees is 3x means 3 into 10, which is 30. So we got the number and we have completed this problem. Hope you understood this. Now we'll move to practice set 4.1. After doing the basics, which is very much required to solve practice set 4.1. Yeah, now question number 1. Just everyone go through it, what they're asking. From the following pair of numbers, find the reduced form of ratio of first number to second number. You have to find its reduced form. Means we have to take the rate of common multiple they are having with them. We should remove the common multiple present with them. First number is first to second number. First is 72, 60. So we have to take the ratio of first to second number. So solution 72 is to 60 is same as 72 divided by 60. As we know that in which table or this both two number having which number has a common multiple? Yeah, think. Take 5 seconds. We know that 60 is divisible by 12 as well as 72 is divisible by 12. Means 12 5s are 60 and 12 6 are 72. Okay, so we can write this as 12 6 are upon 12 5s are. 12 gets cancelled. What remains? 6 by 5, which is same as 6 is to 5. We can say this is the reduced form of ratio of first number to second number. Okay, so you can try the second problem by yourself. That is 38, 57. 38, 57. So again, similar. Solution 38 is to 57. This can be written as 38 upon 57. Now again think for 5 seconds. Which number is the common multiple of both? Yeah, correct. 19. 19 is the common multiple for both. That is 19 twos are 38 and 19 threes are 57. Okay. So since 19 is common, 19 gets cancelled from numerator and denominator. What remains? 2 by 3, which is same as 2 is to 3. Done. So I'll be rubbing upper part. Yeah, try third. Question number 1/3, that is 2,78. Think on this, huh? Without thinking, you won't be able to understand. Once you start recognizing the problem, you can easily solve the problem. Since they're asking reduced form, solution. Now 52 by 78. This can be written as we can see that what is the common multiple? 13. 13 is the common multiple because even you can take 26, 26 twos are and 26 threes are. So okay. What will be taking? 26, 26 twos are 52. Being a student of 9th standard, you should know table till 30. So this is 26 twos are 52. 26 threes are 78. 26, 26 gets cancelled. What remains? 2 by 3. Yeah, so we have completed question number 1. Almas ma'am. Almas ma'am, should I continue? Okay, we'll proceed with question number 2. In question number 2, what is they have given? Find the reduced form of the ratio of the first quantity to the second quantity. Now, they have given quantities with units. So make sure that they are in the same units. If not, then just take rid of it. Rid of it in the sense, try to convert both in the same unit. Unless you convert to the same unit, don't proceed. So, first problem, rupees 700. Since it is rupees 700, comma, rupees 308. The solution, take ratio of both. So 700 rupees upon 300 rupees is equal to rupees get cancelled. Now 700 upon 308. This can be written as we right now we don't have any common material, so start with the basic number, that is 2. 2 into 350 divided by 2 into 154. 2 gets cancelled. Again, gets it can be written as 2 into 175 upon 2 into 77. 2 gets cancelled again. Now, with respect to 25, how much are 25? How much are 725s are 725s are and 77 can be written as 7 into 11. 7 gets cancelled. Now further it won't be getting cancelled. 25 is to 11. 25 is to 11 is the answer. Hope you have understood and you can try question number 2 by using your own tricks. Just make sure that you are converting all the given units to the same form. As we are having liter, milliliter, so try to convert it in milliliter, rupees, paise, try to convert it in paise as whole, years, months, try to convert it in months as whole, kg, grams, try to convert it in grams, minutes and seconds, try to convert it in seconds, and then proceed. So we have completed question number 2. You can try it by yourself. If you want, I will be continuing with some more solving of this question in next lecture. Yes, thank you everyone. Almas ma'am. Almas ma'am. Hope you have understood, students. In case you are having any doubt regarding we know that in 1 rupee we are having how many paise? 100 paise. So 14 rupees can be written as 1400 paise, and 12 rupee 40 paise can be written as 1200 paise plus 40 paise. So which is 1240 paise, 1240. So just take their ratio, cancel with some common multiples, you will get through. Regarding liters and milliliters, 1 liter is equal to 1000 milliliter. So 1 liter can be expressed as 1000 milliliters. So 5 liter becomes 5000 milliliter, and 2500 it is already in milliliters. So milliliter get cancelled. 5000 divided by 25. So answer should be, it's very simple. 0 gets cancelled. 50 upon 25. Answer is 2:1. So problem of this type can be done easily. As my time is done. Hello, ma'am.
Yes, sir. Hello.
Hello, ma'am. I'm done.
Yes, sir. Thank you so much. Thank you.
Okay, ma'am. Thank you.